Hey, good afternoon, everybody. Good to see you guys here. Glad to have you. I have a couple of things I want to set up here real quick before we start. We're done with chapter 7 and chapter 8 now. And so we're going to take a test on chapter 7 and chapter 8 on Monday. It'll be similar to other tests where we've got a little bit of Newton stuff and a little bit of show your work kind of questions. Especially, well, yeah. So that's what we're looking at here. And so I put a few resources for you. There's chapter 7 practice, there's chapter 8 practice, and then there's a combination of 7 and 8 to practice with. I think that chapter 8 practice there is a biggie. It really will challenge you to let you know that you understand the stuff or you don't. This has 7 graphs that I kind of want you to graph by hand without your calculator. So numbers 1 and number 2 are moderate difficulty. So I kind of started out with the secant and the cotangent. Looking back on it, that's probably not the best place to start. Number 3 is a half cosine. That is a simple one there to get started with. So you might do number 3, 4, 5, 6, and 7, and then come back and do 1 and 2. Because this 3 through 7 are all sines and cosines. So you want to get really good at those sines and cosines. Number 7, the difficulty is getting up there to like a 7.5 difficulty, maybe an 8. And so any of these are levels of difficulty that you should be able to do for the test. And so this would show up on the show your work part of the test where you're showing me the formulas, you're calculating the period, the end, and the start, and things like that. Okay. So, and there's answers. So you can check your work down there after you've tried them. I'll leave that there for a moment. You can get kind of a head start. The head start that I'm giving you is I want you to create the equation of this picture. What I'm going to do is I'm going to ask the class a series of questions guiding what you should do to come up with the equation. And then when you're doing something like this on the test, you'll kind of just follow the same process. So I'm going to create a list of people. So I'm not picking on anybody. I'm just going to go write down this random list that I'm creating here. This is just a question for anybody who knows how to start. And then later I'll get more specific, so I'll be calling on people. But I'll just open it wide up here. What is the very first thing we should do to figure out the equation of this picture? Very first thing.
Write out how the equation looks, like a sin bx plus c in the parentheses plus d.
Well, that is actually a good strategy. That's not what I was fishing for, but Toby's right about that. It's good to have the framework to guide you. So we're looking for
the amplitude.
Hold that thought. Let me first take what Toby is talking about. We need an equation. Now we don't know yet. We haven't decided whether it's a sine or cosine. But I'm just going to write a times the trig function b times x plus c plus d. That is the framework that we have to build for. And so we need the structure. That's the equation. It could be a sine or a cosine. And then Caleb was talking about the amplitude. But there's actually something that we need before we do the amplitude. You might be able to do it mentally, but for students who are visual, I'd say there's a really important first step that we should take before we try to figure out amplitude and period and all that stuff. Any other thoughts on what that first step should be?
The midline?
Okay, that's related to what I was thinking. Yes. Make a box, and a part of the box would be a midline. So get that box in there. So you want a box around one complete cycle. Now, the problem is highly suggesting 2 points that we build with. So I'm going to do those 2 points. All right, get a box on there. And I'm thinking we should use this point right here. And I've got a box. I have to make sure I go all the way around a complete cycle. Now what I'm seeing in there is a beginning of wave, up, down, back up again. That's a complete cycle. So get the box. And then related to the box, which was what Toby was suggesting, is the midline. Okay, that is the beginning. We're all set with the starting point. Okay, so now I'm going to start asking specific questions. So I'll give you a second to think about this. I want you to look at the box. The first question is, we wanted to deduce all the information from that box, which is amplitude, period, phase shift, which is also called horizontal shift, and vertical shift. We have to gather all that data off of the box. And the first thing is probably the amplitude. Now, I want you to think about that question. I'm going to call on somebody in a second here. What's the amplitude? Ariel, can you help? What is the amplitude of that trig function?
Is it 1?
It is 1. Very good. Because the bottom is 0, the top is 2, and the middle is 1, and the height is from the middle up, from 1 to 2. And we just take that absolute value of the distance. I mean, if you go from the bottom down, you just take the absolute distance there, and from 0 to 1 is 1. So Ariel was correct about that. Okay. Next thing we should look for in the box is I'll go for the easy stuff to get us started. The vertical shift. Is there a vertical shift? So I want you to take a look at that box. Audrey, I've got you up next. Can you help us out with the vertical shift?
Does the vertical shift refer to D in the equation?
Vertical shift, you're right about that. Vertical shift and D are related ideas. And so if we can see the vertical shift, it helps us get the D number. Do you know what the vertical shift number is?
Is it 1?
It is, yep. So the vertical shift is 1. The vertical shift has multiple ideas with it. So let's see what has happened. Audrey gave us the D number, and Ariel gave us the amplitude number. And now we need to continue and find a couple more characteristics about the picture. Okay, so going down the list, the next thing we should figure out, we've got 4 things. We've got to look at the amplitude, the vertical shift, horizontal shift, and the period. Let's do the period. How long is the cycle? That's the period. And so we want to look at that picture and think about that for a minute. I'll be calling on someone here in a second. Caleb, I got you next here. Can you help us, Caleb, determine the period?
Is it pi over 2?
It is. It is. The way to look at the period is you just find the distance, and you find the distance by taking the end number minus the starting number. And the end number here is 3 pi over 4. And the start of the window is right here. And if we subtract those, 3/4 minus 1/4, we get 2 pi 4s, which reduces as a fraction to pi over 2. That's the period. Okay, we've got all of the parameters figured out except one more. We need one more thing, and that's the phase shift. A lot of books call it the phase shift, and Newton calls it the phase shift, but our textbook calls it the horizontal shift. So it's all about the same. So take a look at that picture there. Faye, you're up next. Can you tell us what that horizontal shift is?
Is it the pi over 4?
It is, exactly. Normally we like to start over here, but the box has been shifted over to the right side, and the box is starting exactly where Faye said pi 4s. Now, from those four things, we have to work backwards to the ABCD numbers. Now, some of the numbers are really easy, like D. Audrey gave us that one already. Oh, wait, one more thing we should figure out is the actual wave. There's two parts to the wave we got to figure out. Is it a sine or cosine? And is it flipped or not flipped? Okay, so I'm going to make this into one question here. Don't say it out loud. We have to look at the box and decide, is this sine or cosine, and is it flipped or not flipped? Kelsey, what do you think? Is it a sine or a cosine?
Sine.
Nice, it is. Is it a regular sine or is it flipped upside down?
Regular sine.
Yeah, it's regular. If it had been flipped, then A would equal a negative number. That's why we need to look and see if the wave is upside down. This one is flipped. And so our A would have to equal a negative if it's upside down. But like Kelsey said, it's not. So we don't have to worry about A being negative. Okay, now we are ready to start deducing the information. So what is the A number? I'll just open this up to anybody. What's the A number?
1.
Exactly. If it was a flipped, we'd say A is -1, but it's not flipped. Okay, the D number. Audrey gave us that one already. And those are the easy ones. The A and the D are pretty direct. Actually, the C number is also pretty direct, but we have to be careful whether we put a plus C or minus C. And we figured out it's a sine. So let's start writing the equation. Y equals 1 times sine. Plus d. But we know d is 1. So we've got 2 of the 4 already. Now, let's see if we can figure out the b number. How are we going to get the b number? So let me just throw this question out. It might be, I think you guys can do it, and but we'll just start. So Madison, what do you think? Do you know a way to find the b number?
Is it 4?
Not quite. Let me give you a little hint and rephrase the question. Madison, do you know a formula that has the b number in it?
2 pi over b.
Nice, exactly. That's an important formula because it tells us a relationship about b. So good, we've got a beginning place. Now 2 pi over b is a formula. And what is that equal to? It's a formula for what? Do you want to keep going, Madison? Do you think you know what the other side of it is? What does 2 pi over b equal?
The period.
Yeah, nice. We got it. So B is the most difficult of the letters A, B, and C, and D. B makes us work the hardest for it. Now, when we looked at the box, we saw the beginning and the end, so we know the period. We know it. It's right here. So I'm going to plug that in. And that period has this formula. And now we can do algebra to answer the b number. It didn't give there, but let me pause. Any questions about that formula? So now we have to get b by itself. And there's lots of ways to do the algebra here. Some of you know about proportions. You can only do that kind of proportional cross multiply if you have a proportion. But generally, when we have fractions, we will multiply by the common denominator. And so I don't want fractions. I'm going to times everything by 2b on both sides because that 2 cancels and this b will cancel. And that way, all the fractions are gone, and I get this new equation. 2 times pi is 4 pi equals pi times b. Oh, my goodness. So Madison was right. You said 4. I didn't. You had gotten, apparently you worked ahead of me and already knew because I didn't know what the b number was. So Madison was right when she said 4. Let's keep solving. Divide by pi. And so we get 4 equals the b number. Everybody okay on that? Any questions?
Are you able to cross multiply to find b?
Yes, so this is one algebra trick where you clear the fractions. Now, if you have an equation that's really complicated with 3 or 4 fractions and you got plus or minuses, that's the way you have to do it, is multiply by the common multiple denominator. However, Kelsey, because it is a proportion, 1 fraction equals 1 fraction. This is only for 1 fraction on one side, 1 fraction on the other side. You have a shortcut strategy, which Kelsey's talking about, and that's cross multiplying. So you get b times pi, and you get 2 pi times 2 is 4 pi on the other side. So it is a little faster when you have proportions, but I didn't know if people knew about that, so I didn't want to throw people off on that. But I divide by pi, and we get b equals 4 again. So either way, b equals 4. Okay, so that takes me to the next part of my equation. I just found the b number. So I'm going to put 4, and then I'm going to put parentheses, because the form of the formula that I'm using is the factored form inside. Now, the c number, we almost are done. The c number is pretty straightforward, except for the plus or minus part. And because we have shifted right, should we have a plus c or a minus c? This is a question for the whole class. I'll leave it wide open. When I put in my x, do I go minus c because I shifted to the right, or do I do plus c because I shifted to the right?
Minus.
Minus.
Good, good. You guys are on this. This is great. And so we can just plug in this number now. We're done. That's a reasonably difficult equation. And we created, I'm sorry, that's a reasonably difficult graph, and we created the equation for it. And it started with a box, and then we found amplitude, period, vertical shift, phase shift. And from amplitude, period, vertical shift, phase shift, we were able to find all the ABCD numbers, and we were done. So that's pretty substantial and pretty significant to me. It's highly likely you're going to see something like this on the test. Most definitely likely that you're going to see something like these on the test. I'm going to give you an equation. I want you to graph it. Let's do one of these together. So it's very similar to what we just did. What we just did is we had a picture. If you have a picture, you have to find amplitude, period, horizontal shift, vertical shift. Once you find those 4 things from the picture, you look at the box, and it tells you all 4 of those. How high is the box? How wide is the box? Is the box shifted left or right? And then once you've got that, you can work over to A, B, C, and D, and then you can do the equation. That's what we just did. Now, we're going to reverse this. We're going to look at the equation. And from the equation, we can find the A, B, C, D numbers. And once we find the A, B, C, D numbers, then we can figure out the amplitude, period, horizontal shift, and vertical shift. And then we can make a graph. That's our game plan here. So it's just the reverse of what we did a moment ago. Okay, so let's look at the equation. Let's write down all the A, B, C, D numbers, and that will help us build our, once we get amplitude, then we can build the box. And then we can graph what's in the box. All right, so on the test, I would like to see all your thinking. So I'm going to grade you on your formulas, your setups, the work you show me. I'm trying to see that you're smarter than a graphing calculator. So if you just punch it into a graphing calculator, I won't be giving you full credit for it. And there's things I can tell when you have done that. And if you show me your thinking, that's one way I know that you're smarter than the graphing calculator. So I'm going to start out by listing out here my A, B, C, and D numbers. And so I'm just going to keep going down my list here. So I'm going to ask for these A, B, C, Ds. And so we'll just start off with the first person here. Think about it for a second. I need to know A. Samuel, can you help us out with A?
It's 2.
Yep, it is 2. Now we need to go to the next one. Serena, can you help us out with the B number?
Two square, or two, I can't remember the name of it.
Are you talking about that little thing right there?
Yes.
That's pi. That's our symbol for pi. So yeah, x is my variable, and 2 pi is what's multiplying the x. So the B number is that is both factors there. Okay, let's keep going down the list. Sherry, what is the C number?
Is it 0?
It is. There's no C's in this problem. So it is 0. And so that was kind of a little bit on the easier side. And then Toby, you got one more of those. What is the D number?
0.
Yeah, so what that means is there is no vertical shift. And Sherry, let me follow up with you. If C equals 0, what does that mean?
Oh, there's no phase shift?
Yes, very good. No phase shift. Newton calls it a phase shift. I don't know. I like to call it horizontal shift because that's the way we learned about it in general in chapter 3. So that's nice because that means I can start on the origin as my box building position. So I don't have to shift horizontally. I don't have to shift vertically. I can keep myself on the origin to get things started. Okay, where does the midline go? So let's start building the box. Where does the midline go? This is open to anybody say.
0.
Yeah, it is the line. It's not just the 0, but it's the whole line, y equals 0. So the midline is right on the x-axis. Okay, and since I don't have a shift, I can start right here, and then I do the amplitude. So what is the amplitude?
2.
Yep, that's pretty direct from A. 2 is also positive, which we got to remember that it's not flipped. So we're going to go up to, I'm going to go back to my orange for the box. Now we're going to go down to next, we need the period. What is the period?
1.
Right. The period has a formula. Now, this is the formula that Madison was telling us about before. There's a formula for period, and we got to use that, 2 pi over b. We know the b number. We can plug it in, and it'll tell us the period. So we're going to plug in b. Well, it just so happens b is 2 pi, and 2 pi divided by 2 is 1 period. equals 1. It's not a fraction of pi. It is a one whole number. So the beginning of the box starts at 0 and it ends at 1. Okay, so where are we going to end this? Well, it doesn't really matter, but so I gave you kind of a structured grid on there, and you got to figure out how do we use that structure, and I'm trying to figure out how to use it. I know the box has to have a width of 1, so I'm just going to randomly pick one of these marks here, and oops, sorry about that. I'm going to call this increment here 1. Now, it is not to scale, because you can see on the y-axis goes up 2, and the x-axis stretches way more than that as 1, so I don't have the proportions right. But that doesn't matter a whole lot. Technically, if this is 1 here, I should put my 1 there. And then that way it's scaled. So I've got 1 on the x-axis, 1 on the y-axis, and they're the same proportions. But if I make that x1, it's going to be way too tiny for me to sketch in a wave. So I don't want to try to force in a graph of a sine wave into that little tiny space. So I'm not going to worry about the proportions. And I'm just putting the 1 out here for convenience, because then I can build a box and it will be easier to graph my wave in it. We're pretty much done. Once you've got the box, it's almost completely over. Now, if you want to get an A on this question, not just a B on it, you have to scale the x-axis. I want the x-axis incremented with all of the tick marks in between. This one happens to be particularly easy because we're going to take the period of 1 and cut it into 4 subdivisions. So what is this x amount right here? What is that x number?
Half.
It is, because this x number is 1. So we're cutting the box in half. This is how you always graph. You need 4 subsections. So you cut the box in half. And then you cut each half in half. Okay, so what is that x number?
1/4.
Exactly. If you cut a half and cut it in half again, you get 1/4. And so this means the tick mark, the distance of the tick mark is 1/4. So this next one is 1/4. This next one is 1/4, which makes that 3/4. Now these are not fractions of pi. Often our periods are fractions of pi, but notice back here that the pi's canceled out, so it's a whole number. And therefore, I can subdivide the whole number into 1/4, 1/2, 3/4, and a whole number 1. That's the whole period. So sometimes that's a little trickier to do if you got fractions. And it's really trickier to do if you have a horizontal shift. So if you got to shift it, then your starting number isn't on 0 anymore. And so, and lastly, we need a sine wave. So we've got the quarter marks plus the beginning. And where does the sine wave begin? You need your 5 target points. Where do they go?
Hmm.
Well, here's my first target somewhere on the beginning. Where does it go? Top, middle, or bottom?
Middle at
Middle.
0, 0.
Right, it goes in the middle. Here's my next target. Where does it go? Top, midline, or bottom?
The top.
Top.
Top?
Yep, good job. Okay, you guys know this is the sine wave, so I was belaboring it, but it sounds like you guys got it. There's the target points. Now, round those curves, connect the dots, and we're done. We sketched one complete cycle of that equation. While we're at it, what if it says graph 2 cycles? It doesn't, but wait, I should pause. Any questions about getting that graph? All right, what if it says graph 2 cycles? How do you do that? Well, don't worry about it. Don't worry about graphing 2 cycles. Just get one period, one cycle perfectly plotted in. So if the domain is like a weird domain, don't worry about it. Just focus on the beginning and the end and get a box for one cycle. And then just follow the directions to fill in if they ask for a bigger domain. And so if in this case, if we want to graph 2 cycles, we're going to need to add another box. And once you've got the first box, it's just copy and paste. That's all you have to do is copy and paste. So if the period is 1, then the next box is also a period of 1. So this distance equals 1. Now, if I'm starting at 1 and add 1, I'm going to end at 2. And if you have the first box perfectly matched in and the x-axis all incremented out, I'm happy because then I know that you understand the x-axis, you understand the period, the horizontal shift, and so all of that's taken care of when you can label the x-axis like that. So the second box I don't care about that much because I know you already can do it from the first box. So the second box, just put in your target points. Oh no, I need a quarter mark and a quarter mark, and then I'm going to put in my targets. And so I'm not doing as many details on the second box. I just had to make sure it ended at the correct number. But that was easy because the period was 1, and so I added the beginning at 1 and ended at 2. All right, so there's some examples of graphing trig functions. We went both ways, from an equation to a graph and from a graph to an equation.